Ever wondered how the small, squiggly grain of rice you eat makes its amazing journey from a dirty field to your plate? And it's a process that takes the old tradition and the future-facing innovation and blends them. Today, we will delve into the amazing tale of how technology for modern rice agriculture has revolutionized the process of growing, harvesting, and much more. From immense muddy fields that extend to the horizon to the skyscraping machines that pick them clean in one go, what you're about to see will dramatically alter the way you look at this modest grain. Till the end, stay with us. You'll never look at your next bowl of rice the same. Rice functions as a vital agricultural product that sustains the daily nutrition of more than 50% of Earth's population. Trillions of people worldwide consume rice as their dietary foundation, while it functions as an economic cornerstone and traditional base and a cultural center throughout the world. It's found in billions of diets and is a cornerstone in economies, cultures, and traditions around the world. Rice is grown all around the world, adding up to more than 500 million tons produced annually. And the story behind these huge volumes is a really interesting tale, driven by science, technology, and downright human effort. Millions of jobs depend on rice farming, from small-scale producers in Asia to industrial-scale farms across the Americas. It is also associated with festivals, rituals, and daily life in many people's lives, and represents prosperity and even life itself for many cultures. In today's video, we are taking this to the limit, exploring every phase of the rice farming process, from leveling the fields and growing the crop to the insane machinery used to harvest it, and the meticulous techniques to dry, mill, and ship it to your table. And we'll also look at cutting-edge new developments in sustainable farming and the future of rice farming and production. Where to begin? Well, actually, from the very beginning, prepping the rice fields. Preparing the fields. Farmers need to execute precise planning when preparing their fields before any rice seed becomes capable of growth. Rice demands moist conditions for its receptive development stage, unlike other agricultural plants. The fields that receive planned floods achieve the most productive conditions for the rice plant to grow. The necessary step for farmers is to create flat fields that allow water to be distributed uniformly. The modern method for field leveling relies on laser-operated tractors to create perfectly flat surfaces. Field leveling prevents water from forming irregular pools that would result in rice death or desiccation on specific sections. The fields receive water from river sources and reservoirs and underground well supplies following the leveling process. Today's irrigation controls use automatic gates alongside sensors for maintaining the perfect water levels necessary for plant growth. The implementation of GPS and GIS, Geographic Information System mapping, enables modern farms to develop and supervise field arrangement while maintaining complete coverage of all areas. After field preparation, the farmer starts with planting activities. Farmers use two planting methods for their crops based on their selected farming system, either by broadcasting dry seeds into wet fields directly or through nursery bed production before field transplanting. The process of transplanting seedlings into main fields requires mechanical rice transplanters for large operations to plant thousands of seedlings each hour. Growth and crop management. The planted rice progresses through amazing developmental stages that need proper attention during its course. First, the plant roots itself while developing its shoots until it becomes established. Tillering starts as the plant develops multiple stems, referred to as tillers, that will produce grains in the future period. The rice plant moves into the panicle initiation stage following tillering, so the grain-bearing section starts to develop inside the stems. Flowering begins after pollination, succeeds to establish the grain number, which triggers the ripening process and results in plant color transformation from green to golden. The farmer plays an essential role in these rice growth stages. The fields receive frequent inspections as the goal is to detect pests and diseases, along with nutritional issues. The industry of modern rice farming depends on high-tech tools, including soil moisture sensors and aerial drone imaging, together with AI-driven apps that provide live crop condition updates. Application techniques for fertilizers include variable rate techniques, which precisely deliver required nutrients to individual portions of the field without producing any waste. Modern agriculture controls pests through integrated pest management, IPM, by utilizing limited chemical substances through variety selection and precise spraying techniques, together with biological control methods. During months of care, the farmer let the rice mature toward harvest, facing multiple weather conditions and natural threats. Rice changes from green to golden fields when it matures, since this signals the start of harvest season. Modern harvesting technology. The most important stage for rice cultivation occurs when farmers perform the harvesting operation. The harvesting time must be perfect since harvesting before maturity results in poor milling quality grains, yet harvesting beyond maturity triggers shattering, where mature grains drop before collection. Large-scale farms now use powerful combine harvesters to accomplish field-wide harvesting, threshing, and cleaning in one operation that was previously done manually by tradition. The heavy automatic machines weighing several tons function effectively in muddy fields because their design prevents them from getting trapped. The machine's sharp cutting blade operates at the bottom part of plants while traversing the fields. Plants move through the machine to split grains from stalks using mechanical force, together with airflow through rotating drums. The cleaned grains result from the machine using sieves together with strong fans to eliminate husks and leaves and other waste. Farmers maintain continuous moisture readings since high grain moisture speeds up the spoiling process. Farmers verify grain moisture content using small portable meters to determine the immediate suitability of crops between 20 and 24% moisture. The rice harvesting machine collects harvested grains in internal storage tanks, which function as the receptacle. The tanks reach complete capacity before trucks or trailers receive material through gravity chutes or conveyor belts, which prepares it for collection by drying facilities. Drying the harvest. Rice must not be put into storage as soon as it is harvested due to the high levels of moisture, because the grains become susceptible to contamination by fungi and start deteriorating in quality. The subsequent necessary step for harvest preservation is drying. The current drying operation employs vertical towers that incorporate heat exchangers and strong blowers to process rice. The towers accept rice loads that receive heated air, which runs through the grains under temperature control until the moisture level reaches 12 to 14% for safe storage and milling. The preservation process depends heavily on proper drying methods because any damage must be avoided. The rapid drying process of rice might cause internal grain fractures that result in severe decreases in market value from increased broken kernels at milling time. Such advanced dryers operate using automatic tools for temperature control and humidity adjustment to manage drying parameters continuously while protecting the grains from damage. Special drying systems use multiple dehydration stages so that efficiency meets grain preservation requirements. Solar dryers remain usable on farms that receive bountiful sunlight, since farmers utilize transparent protective covers to access solar energy for drying purposes. Modernized drying systems employ temperature sensors and adjustable vents, and moisture monitoring tools to stop overheating and achieve consistent batch results. Suitable drying procedures allow the inhibition of mycotoxin production along with pest prevention. The dried paddy enters large storage facilities, which contain climate-controlled warehouses using aeration systems to preserve grain quality before the milling process. Milling and processing. Process milling changes paddy rice into the white polished product and brown nutritious rice, which consumers recognize. The first operation involves cleaning foreign objects like stones and straw and dust through the combination of vibrating screens and magnets with air blowers. The paddy moves onto a hulling machine to take away its outer husk layer. brown rice persists as an edible substance that retains its bran layer because this layer contains important vitamins and dietary fiber. Modern equipment in milling machines allows operators to smooth brown rice grains through surface contact without damaging their structure to produce desired white rice products. The latest milling operations follow robotic automation systems running special computer software to optimally control all manufacturing steps for better yield results and higher product quality. The fundamental functionality of optical sorting machines consists of maintaining product quality standards. The high-speed machines operate at an individual grain level to check each grain with high-resolution cameras before ejecting discolored, broken, or defective grains through precise air pressure. A final grading operation separates rice grains based on their dimensions and forms to maintain consistency in the final consumer product. Packaging begins only after quality control assessments are completed. Global food manufacturers perform random testing of moisture content alongside whiteness and chalkiness measurements and cooking properties tests to verify that all rice bags adhere to industry standard specifications. Packaging and distribution. The rice shifts to packaging procedures after completion of the milling and grading steps. Aircraft weighing systems operate on automated production lines where they precisely measure rice quantities for different package capacities, including both retail and industrial bulk sizes. Heat sealing machines or stitching equipment prevent contamination as they close the bags for transportation and storage needs. Packaging facilities in the present era use sophisticated labeling equipment that produces weight information as well as nutritional details and expiration marks and traceable QR codes. Several brands present data about the farming location of their rice production, which allows consumers to become more aware of the origin while developing directly traceable connections to their sources. The rise of smart packaging innovations includes both resealable pouches and biodegradable materials that embrace the current environmental consciousness. Robotic systems arrange package bags into optimized and balanced pallet configurations for stable stacking after packaging. The palletized goods receive protective film wrapping that safeguards them against moisture while also protecting them from dust. The packed rice proceeds to distribution following truck, ship, or train transport, which uses advanced logistics monitoring technology. The processing facility distributes rice through wholesalers into retail stores that eventually reach consumers in their homes, as well as food service providers and restaurants throughout the world. Sustainable rice farming technologies. Rice farming adopts rapid changes as the global community shows growing awareness of environmental sustainability. The water-saving alternative wetting and drying (AWD) technology allows paddy fields to dry periodically instead of maintaining constant flooding. AWD technology helps farmers cut down their water usage by a maximum of 30% while dramatically minimizing rice field methane emissions. AWD enables the preservation of water resources along with reduced agricultural expenses while making crops more resistant to challenges. Precision agriculture is emerging as a notable force in modern agriculture. Through drone and satellite observations combined with AI analytics, farmers achieve crop health assessments to identify disease risks while directing precise applications of fertilizers or pesticides across targeted areas, which minimizes supply waste and environmental deterioration. An advanced soil sensor, when combined with smart irrigation technology, creates superior levels of farming precision, which results in healthier crops with improved yields. The development of rice strains through genetic methods enables crops to resist drought and floods and thrive across different salt conditions, which secures the future harvests from climate change. Scientists have initiated biofortification programs by breeding plants containing elevated iron and zinc nutrients to help resolve worldwide starvation problems. The modern pursuit of rice cultivation has evolved into a system that protects the environment while raising farmer income, while maintaining sustainable food availability for upcoming future. The convergence between governing bodies and nonprofit groups alongside farming collectives quickens the acceptance of sustainable farming measures that lead to an environmentally friendly and durable agricultural domain. Conclusion: a grain with a global story. Behind every tiny grain of rice lies a monumental story of human innovation, perseverance, and evolution. From the ancient paddies tended by hand to today's laser-leveled fields monitored by satellites, rice cultivation has come a long way. The next time you enjoy a simple bowl of rice, remember that it represents months of care, cutting-edge technology, and the relentless hard work of millions of farmers around the world. It's more than food. It's a global achievement. Rice represents an enormous human achievement in innovation through historical development and the persevering evolution of agricultural techniques. A profound change occurred in rice cultivation from when humans used their hands to cultivate ancient rice paddies to modern-day fields, which satellites observe for management purposes. The simple rice bowl you eat emerged from 9 months of agricultural care, together with modern technological advances and countless hours of dedicated farmer labor worldwide. More than being a mere meal, it represents an accomplishment that affects the entire planet. Don't forget to subscribe to our channel for more exciting material about modern farming and food product production after you hit the like button and share the video with your friends. Share your thoughts by commenting on the topic you'd like us to cover next about crops and farming technology in the following section. Continue your exploration while you stay curious about the extraordinary path that leads to your meals.